Hey everybody, how's it going? Brandon Bro here. In this video, we're going to be talking about one of the biggest problems in the Claptrap build, and that's getting him to balance. Before we get into that though, I want to give a really big thank you to all the people that have liked and subscribed to this channel. Because as someone who just made it to have some fun and maybe provide some education, it's reached over 100 subscribers, and that means a lot to me. So thank you. I hope you continue to enjoy the content. Make sure you stick around to the end because I have something that you might all be interested in. Now, when it comes to balancing Claptrap, we're going to have to address one of the most common problems in control theory, and it's called the inverted pendulum. Now, if you think of a regular pendulum, if I take this tube here, and I just let it fall, eventually it comes down center, it finds its balance point or equilibrium, and it's considered a stable system. Now, an inverted pendulum, on the other hand, is like balancing that same tube on your hand. And it can be fairly difficult because you have to be constantly making adjustments and try to get it to balance. And that's exactly what we're going to be doing with Claptrap. When it comes to balancing though, humans and robots obviously do things completely different. Humans utilize some semicircular tubes in their inner ear that help them get themselves oriented. Robots, on the other hand, don't have inner ears, but they do have sensors that allow them to gain their orientation in space, and those are called gyroscopes and accelerometers. In this project specifically, we're going to be using one called the MPU 6050, which actually incorporates both of those together. But enough about that stuff, let's go ahead and get into the build. To get Claptrap to balance properly, we're going to need three critical parts. Those are the Arduino Nano, the MPU 6050, and lastly, the ODrive. The Arduino Nano will be the brains of the whole operation, taking signals in from the MPU 6050, which is going to be telling us which way Claptrap is leaning, left, right, forward, or back. Any kind of error that is calculated will be sent out via serial, which is this black and white line here, to the ODrive, which will turn the wheel to try to correct Claptrap and let him balance. I am a huge fan of iterative design, so making sure that one thing works before moving on to the next. So the first thing I'm going to do is make sure that the Arduino Nano and the ODrive communicate properly and go from there. So let's hop on over to the Arduino IDE, load up some script, and see how it goes. The developers of the ODrive actually created a Arduino specific library which can be obtained through their GitHub repository. This includes things such as calibrating the motor, testing it, and even getting V-bus voltage. Now, I've already done the calibration of the motor through the ODrive setup, so we don't have to worry about that, just the test move itself. So I'm going to delete a lot of the extra code here and adding in two commands that will be entered over the serial monitor. And those will be T to start the test and then S to stop the test. So let's go ahead and get this loaded up onto the Arduino and see if we can get proper communication. Alright, so at this point we have our Arduino sketch all made up. It's loaded up onto the Arduino. The next thing that we have to do is get everything hooked up, which I've already done, and I have two 4S batteries wired up in series, so it's providing about 32 volts to this motor and should be able to provide enough amperage that we need to drive it. So let's go ahead and test out the code and see if it works. Opening up the serial monitor. I'm going to go ahead and type in T, and there we go. Working. All right, and let's go ahead and stop it. And there we go. Down to 0 again. So now we have identified that we can properly communicate between the Nano and the ODrive, so we can move on to getting the MPU 6050 and the Arduino. Let's get to it. When using any kind of sensor, it's a really good idea to make sure that it's calibrated properly. The MPU 6050 is no exception. Thankfully, there's a really good set of code here in Arduino that helps us do that. So I'm going to run that, and it's going to provide some offsets. Now, these offsets let the program know
which orientation that sensor is in, because the orientation that I use may not be the same as the next person. So after this program runs, it's going to give me some offsets just at a quick glance, and then it's going to go further into it to really zero in to make sure that everything is calibrated exactly how we want. I'm going to grab those numbers and we're going to use them later on down the road. Now that road, on the other hand, is not very long. In fact, we're going to plug those offsets into this next program, which is really going to give us a readout of what that sensor is doing. So I'm going to load up this new code, enter in my offsets, and what we should see over the serial monitor is any kind of change in the orientation of the MPU 6050 should be shown on screen. Another thing when you are doing this, make sure that your baud rate is set properly. And if you have them set improperly on your serial monitor, you're just going to get a bunch of gibberish. So make sure that you have the baud rate set. And once we get that done, we can get the readout. You can see over the serial monitor that as I tilt the sensor left, right, forward, and back, we can get some different readings. So that would be a clear indicator that our sensor is in fact working properly. It's communicating with the Arduino Nano, so we can move forward in the project. Here comes the beauty of YouTube, where you only see a few moments, when in reality this took me a couple of weeks to actually get coded out. In the beginning of the program, I am setting up my PID loop and the variables used for it. So that's the set point, the P, I, and D. Further down, I am entering those values that we got from the MPU 6050, those offsets, making sure that our program knows the orientation of that sensor. Beyond that, I'm setting up the PID loop and its output limits. Now this may not seem like much, but the negative 1000 and positive 1000 will come into play a little bit later on in the program. So here we are actually computing that PID loop, and as you can see, I am mapping, or what's called mapping, so taking that negative 1000 to positive 1000 and transposing that into something that's more usable for our motor. So here you can see I have it set to -9 and +9, and that's really the amperage that will be applied to the motor. After that, I enter into an if statement, so if Claptrap is falling forward or if Claptrap is falling backward, I'm going to apply a certain amount of current to that wheel to try to correct for it. And lastly, down here, this is where I grab all the information from the MPU 6050 and convert it into something that is more easily manipulated for programming. So let's go ahead and get this loaded up onto the Nano, see how it runs.
Alright, so we've got everything hooked up. The only thing that I have left to do is to plug in the battery and testing to see if changing the orientation of the MPU 6050 is going to have any change in the direction of the wheel or how fast it's going. So let's go ahead and test that out. Alright, so it moved a little bit, but not getting anything right now. Let's go ahead and reset the Arduino. Oh, we're getting a little something. Alright, so we are in fact getting some movement. I do have a sneaking suspicion though that because the values in our PID loop are so low, it's actually making it so that this motor isn't turning like we want it to. So let's make some changes to the code and test it again. Alright, so at this point, we have a motor that responds very quickly to me tilting the whole setup. So next thing to do is go ahead and give it a shot in the upright position. Alright, so I've got everything all set up. I have the program loaded up, I've got Claptrap upright. I placed the ODrive, Arduino Nano, and the NP6050 up top. And the reason why I did this is because the further you are away from your point of rotation, in our case the wheel, the faster you're going to realize that something is wrong. So I decided to place all of that up top, that way I'm going to have the fastest readout as possible. So I'm going to go ahead and plug in the batteries and see how it runs. Oop. Alright, so it tries to catch itself, but at this point it's just really sluggish. So it'll try to turn the wheel, but it's not doing so fast enough to actually keep him upright. So I'm going to go ahead and make some adjustments to the code, changing that PID loop values, and see if we can get this to balance any better. Alright, so we're getting some results, which is good. Let's try to fine tune it a little bit more. Alright, so I think the program just stopped working there, but before that it was working really good. So let's go ahead and give that another shot. I'm going to restart the Arduino and see how it goes. Alright, so this is a good time to bring up a point. When it comes to balancing robots, it's very important that all of your components, the frame, the wheel, even the sensor, is very securely fastened, because that balance point that it's always trying to achieve, I can tell the program stopped working because now I can rotate it. If everything's not rigid, it's always going to be trying to compensate for that. And because my sensor is not very well secured. It's just pressed into the breadboard. It has some room to tilt just a little bit, and that can throw off that set point that we're constantly trying to achieve. So if I restart this, I'll show you what I mean. Okay, so the set point right now seems like it's okay. It wants to go that way though. Now, if I just slightly press that, now it wants to go that way. And you can see if I just tap it, now it wants to go even further. And if I pick up on the sensor, it automatically tries to adjust. So when it comes to the final claptrap, design, I'm going to have to make sure that that sensor is really set in stone. That way, if he does happen to fall over, which is, I think what happened was he hit this table and it threw that sensor off a little bit. So, but overall, I think that, I mean, he's balancing right there, right? No interference, no hands, no nothing. And he's doing a really good job of balancing. So, really the only thing that I think that we have left to do is really test this out Boston Dynamics style. Oops. So he's got a little bit of oscillation there. I mean, that's working pretty good though. I think that once I get the stabilization for roll, Claptrap's going to be able to balance really, really well. Little bit of oscillation there, but he does come back eventually. So that'll require some fine tuning, but there we go. That's Claptrap balancing. So, I mean, boom. And there you have it, everyone. That is us completing one of the hardest steps in this Claptrap build, and that's getting him to balance, at least in the pitch axis. We still have to get him balancing in the roll. As you may have noticed, I had to tilt him left or right to keep him from falling over. And I have some plans on how to accomplish that, but that'll be done in the future. Now, at the beginning of the video, I asked you guys to stick around. To give thanks to all the people who are viewing this channel, I wanted to hold a random drawing for a winner of an Arduino Nano. I do a lot of building and I have a lot of fun in it, so I want to promote that kind of same excitement in other people, in someone who this might be their first chance to have some kind of building experience. So you got to do 3 things for me. 1, go ahead and hit that like button. 2, make sure you're a subscriber to this channel. And 3, leave a comment down below as to what you would like to build with an Arduino Nano. So if you're interested in entering for that drawing, make sure you do those 3 things. Thank you so much for joining me. It was a blast. And until next time, take care. Bye-bye. Oh, coming back.